Hi everyone. Let's resume to our Aeon topic which we left yesterday. We are not empty. So let's resume where we left yesterday. I guess this one. About the two quantum property about this bleak fate. So let's read the first property of the first quantum property which avoid the bleak fate. The first property arises from the Heisenberg uncertainty principle, which holds that a quantum particle cannot simultaneously be at a precise position and also have zero speed. This implies that an electron cannot glue to a nucleus because both particles would be in well-defined place and at rest to each other, defying a central rule of the quantum world. So first property, so the title of this particular passage is the first property of quantum. So first property says that the quantum particles cannot simultaneously be at a precise positions which have a zero speed, which implies that the electron cannot glue to a nucleus because both particles would be well-defined place and at the rest of each other, defying the central rule of quantum world. So we just there is not a point. I think the whole passage is important. We can't just neglect any point over here. So we just summarize this particular passage as that the first property implies that the positions of quantum particles which also have a zero speeds, which implies that an electron cannot be glued to a nucleus because both the particles would be in a well-defined place and rest to each other. So let's moving toward the second property of the quantum. The second quantum property is the Pauli exclusion principle. The fundamental components of matter are split into two types, bosons and fermions. The gluons inside the proton are example of bosons. We can have as many of them as we want, sharing the same position simultaneously. On the other hand, fermions such as electrons, quarks, protons, and neurons obey a much more restrictive rule named the Pauli exclusion principle. No two identical fermions can simultaneously occupy the same space and have the same spin, a quantum property analogs to a classical rotations of a particle about it exist. So the second property telling that the fundamental components of matter which is split into two types, boson and fermions. And it is said that the gluon with inside the protons are the example of boson. On the other hand, fermions such as electrons, quark, and proton or neutron obey a much more restrictive rule named the Pauli exclusion principle, which is no two identical fermions can simultaneously occupy the same space and have the same spin. That's all for this passage. Let's moving toward the next series. In the quantum world, the wave function represents more than a mere lack of knowledge. So let's see what this series holds. The first passage of this particular series is with all those effects encoded into these Schrödinger equation, the master equation of quantum theory, it predicts that our point-like nuclei and electron must, in fact, behave like waves. They delocalize in quantum cloud much bigger than their particle picture size of satisfying the Heisenberg's uncertainty principle. With electrons shaped into different clouds to satisfy the Pauli exclusion principle, the lighter the particles are, the bigger the delocalization. Thus, a single electron cloud may spread over a multiple nuclei, forming a chemical bond and stabilizing the molecule. So this passage is saying that according to the Schrödinger equations, it predicted that our point-like nuclei and the electron must behave like waves, which is bigger than their particle picture size to satisfy the Heisenberg uncertainty principles. That electrons shape into different clouds to satisfy the Pauli's exclusion principle. It is suggested that the lighter the particle are, the bigger the delocalization is. So the resultant is the single electron cloud may spread over multiple nuclei, forming a chemical bond stabilizing the molecules. So that's all for this passage. Let's moving toward the next one. Take an ammonia molecule, NH3, illustrated below. The small blue smudge in the middle of the nitrogen nucleus cloud, while the three green blobs are proton, which is hydrogen nuclei cloud. The electron of the ammonia molecules delocalize into the fat yellow cloud, tying the party together. So the whole descriptions is about these pictures that about this blue smudge around this nucleus cloud, nitrogen nucleus cloud, this three greens bubbles which are proton clouds, and the 10 electrons of the ammonia molecules delocalize into the fat yellow cloud, trying apart together. So this is description what's given in this picture. So let's moving toward the next species. A particle like nitrogen nuclei has a 3 FM radius. However, in ammonia molecule, the nitrogen nucleus grow to a respectable 3000 FM radius due to the delocalization. The delocalization of the hydrogen nuclei is even more impressive. They grow from a radius of 0.9 FM when seen as particle to cloud of about 23,000 FM. But the electrons take the cake. Due to their tiny mass, they grew from particle much smaller than a nucleus into a cloud that define the molecular volume. So this passage is talking about the different nitrogen nucleus. It is given that like the above nitrogen nucleus which have 3 FM radius, there is ammonia molecule. The nitrogen nucleus in ammonia molecule, the nitrogen nucleus grown to respectable to 3000 FM radius due to the delocalizations. They grow from a radius of 0.9 FM when seen as a particle to cloud about 23,000 FM. But the electrons take the cake due to their tiny mass. They grow from particle much smaller than a nucleus into a cloud that define the molecular volume. So long. Let's moving towards the next species. Nuclei and electrons, however, are not atomic giant. If the nitrogen nucleus is measured, for instance, by throwing a fast electrons against it and observing them bounce back, the nucleus cloud would immediately collapse into the initial 3 FM dots. The same is true for each electrons. So here this passage is talking about that nuclei and the electrons are not that much of atomic giants. If the nitrogen is measured, the nucleus cloud would immediately collapse into initial 3 FM dots, which is also true for in case of electrons as well. So let's moving to the next species. Indeed, quantum theory prescribes a precise relationship between the wave and the particle picture. The cloud of the wave picture are mathematically described by a wave function, essentially an equation that attributes an intensity to every point in space and how this intensity changes with time. The wave function is analogous to the mathematical function describing conventional sound of water waves, but the peculiarity that it has an imaginary number components which is negative when squared. So this passage is talking about that the quantum theory prescribes the precise relationship between the wave and the particle picture. The equation that attributes an intensity to every point in space and how this intensity changes with time. It says that the wave function is analog to a mathematical functions which describe the conventional sound of water waves, but the peculiarity that it has an imaginary number components which is negative when it's squared. So let's moving towards the next business. The square of the wave function molecule is a mathematical operation that always yields positive number, gives the probability of finding the particles at each point in space if we attempt to observe it. The denser the cloud, the bigger the odds of observing the particles there. Thus, if we try to measure the point like nitrogen nucleus, we are sure that it will be somewhere in the region of the delocalized nitrogen nucleus cloud, the blue smudge in the figure. So, this paragraph saying that the square of the wave function's modulus gives the probability of finding the particle at each point if the space we attempt to observe it. It says that the denser the cloud, the bigger the order of observing the particles there. It is given that the delocalization nitrogen nucleus cloud, the blue smug figure, is major point in nitrogen nucleus. So let's moving toward the next basis. However, interpreting the quantum cloud as probability does not mean it is just a measure of lack of knowledge about the system. If I left my keys in one of my jacket two pockets, but I'm unsure which one, I may write a probability function with a 50% value at each pocket and 0 value at every other point of my office. This function obviously does not imply that my keys are delocalized over the two pockets. It just stated my ignorance, which can be easily fixed by checking the jacket. So here author is talking about the delocalization by giving the in general examples of keys. Means the author is trying to say here is that the interpreting the quantum cloud its probability does not mean it's just a measure of lack of knowledge about the system. So let's moving toward the next basis. If the quantum world, the wave function represents more than a mere lack of knowledge, delocalized systems like nuclear and electronic clouds cause a phenomena that localized particles cannot explain. The existence of chemical bonds forming a molecule is a direct example of effect of electronic delocalizations. In the case of nucleus delocalizations, one of its main effects is to boost the changes of a hydrogen nucleus, a single proton, flowing from one molecule to another nearby. The kind of enhanced proton transfer has dramatic biological consequences like increasing the acidity of specific enzymes compared with how acidic they would be if hydrogen nuclei behave as particles. So this paragraph is talking about the functions represent more than a mere lack of knowledge in quantum. Like the same, the delocalized systems like nucleus and electron clouds cause the phenomena that localize a particle which cannot be explained. The existence of chemical bonds molecule is direct example of the effect of electrons delocalizations. So one of the main reason effect of this delocalization is the changes of hydrogen nucleus from one molecule to another, which resultant the proton transfer has dramatically biological consequences, like increasing the acidic of specific enzymes, which compare to the how acidic they would be if the hydrogen nuclei behaved as some particles. So let's moving toward the another pieces. Although electron clouds are commonly depicted in popular science and chemistry, delocalization of the nucleus is often interpreted as vibrations and rotations. But these are only the classical albeit helpful analogies. From a quantum perspective or for the conceptual consistency, nucleus should be depicted on the same footing as electrons at clouds as well. So this passage is talking about the electron that the delocalization of the nucleus is often interpreted as vibration and rotations. And it's depicted on the same footing as in electrons as well as on the clouds. So let's moving toward the next basis. Yet another misconception is that atoms are empty because their mass is in their nucleus. The atomic mass indeed highly localized in an ammonia molecule. 82% of mass is in the blue smog of the nitrogen nucleus shown in the figure 1 above. If we add the mass of the 3 green protons cloud, they account of 99.97% of the total. Thus, a big yellow cloud of the electrons carries only 0.03% of the mass. So here this passage is saying that there is a misconception that atoms are empty because their mass is in their nucleus. No, it is which is not true. Atom mass is indeed highly localized. It's stated that 82% of the mass is in the blue smog of the nitrogen nucleus shown in the figure 1. If we add mass of the 3 green protons clouds, they account to 99.97% of the total. Thus, the big yellow cloud of the electron carries only 0.03% of the mass. Okay, so let's moving to the last passage of today. The association between this mass concentration and the idea that atoms are empty stems from a flawed view that mass is the property of matter that fills a space. However, this concept does not hold up to the close inspection, not even in our human scales world. When we pile objects on top of each other, what keeps them separated is not their masses, but the electric repulsions between the outermost electrons as they are touching molecules. The electrons cannot collapse under the pressure due to the Heisenberg's uncertainties and Pauli's exclusion principles. Therefore, the electron's electric charges ultimately fill the space. So this passage is talking about that the concept does not hold the close inspections, not even the human scales, that when we pile the objects on top of each other, what kept them separated is not their mass, but the electric repulsion between the outermost electrons at their touching molecules. So that's all for the today. Hope we meet tomorrow with the new series of the pieces.